Okay, welcome to 6.3, Function Operations and Composition. Super fun. So the main thing when we get to composition is to just go slow, write the notes, pause, rewind, because that's the tricky part. But we're going to start with just the basic operations: addition, subtraction, multiplication, and division. So let's see, we're just going to combine functions like you normally would from chapter 5. So f of x and g of x are just regular functions, and those are some examples over there. The domain, however, can be a little tricky. So the main thing we are worried about is if we're dividing by 0. So with division, if h of x, let's see, we'll take h of x, right, for our example, 5x over x plus 2, we want to put any number in for x and get a real number back. So the only thing we're worried about is, for this one, is if we are going to divide by 0. So I don't care what happens with the 5x, but I want to look at x plus 2. I'm going to set that equal to 0 and solve for x, and x is going to be equal to -2, which means if I plug -2 in for this x, I'm going to be ending up dividing by 0. So our domain for this function is going to be all real numbers except x equals -2. Right. Another example, just to clarify, so if we had f of x equals x squared plus 2x plus 1 over x minus 6. Again, I want to figure out what the domain is. I don't care about the numerator. That can be anything, because 0 divided by any number is just 0, but I can't divide by 0. So I look at the denominator, and you could probably guess it right now, but just in case you can't. So x minus 6 is equal to 0. When I solve for x, I get x equals 6, which means if I plug 6 in for my x, I'm going to end up dividing by 0. So our domain is going to be all real numbers except x equals 6. Right, so that's a little how domain works. If our function, another example, if our function, let's call it g of x, was equal to the 4th root of x, right, the domain would have to be, let's see, I can't take a 4th root of a negative number and get, even if it's like something like -16, I can't get a real number back. So I can't have any negatives because it's a 4th root and it's an even index. So if you remember from 6.1. So my domain is going to be, x is going to be greater than or equal to 0. So 0 works in anything positive. So that's a little bit how domain works. All right, so for example 1, we're going to just do addition and subtraction, and then we're going to find the domain. Right, so for example 1, or example A, so f of x, we're going to substitute f of x is equal to 4x to the 1/2 power. And g of x is equal to -9x to the 1/2 power. So and for part A, we're adding them. Okay. And then let's see, we're going to combine this and get 4 minus 9. And we have the same base of x to the 1/2 power. And that is the same thing as -5x to the 1/2 power. And if you'll remember from 6.1 and 6.2, we can also rewrite this as -5, and this would be the square root of x, which normally we don't put the 2 there. But that is A when we add the functions. Now let's do B. So B, we're going to subtract them. So we have, again, f of x is this, 4x minus 4x to the 1/2 power. We're going to subtract -9x to the 1/2 power. Right, so that will turn into a positive. And then we're going to have 13. And and then x to the 1/2 power. Okay, and we can also write that as 13 times the square root of x. Those are equivalent, right? So now we're going to find the domain. So the domain for this one, well, to get a real number back, so I'm going to plug in a bunch of x's, and to get a real number back, since the square root, it's an even index, x would have to be greater than or equal to 0 in order to get a real number back. Nothing with imaginaries. And then for this one as well, since this is a square root, domain would have to be x is greater than or equal to 0. So I could plug 0 in and get a real number back, and anything positive. Right, so that's how you do those examples. For example 2, we're going to be multiplying and dividing. So if f of x is 6x, and then we're going to multiply by g of x, so x to the 3/4. Right? So that's how you set up A, and then we're going to use our exponent rules. So this is 6x to the first, so that x6 is a base, and it has an exponent of 1 as well. And so when we multiply, we're going to keep our 6, and then for our x base, we need to add these exponents. Okay. All right, so when I add the exponents, let's see. I'm trying to add 1 and 3/4 together. So I'm going to multiply 1 by 4/4, so they have the same name. So I have 4/4 plus 3/4. So I keep the same name and I add the top, so that would be 7/4. Okay. So I still have my 6. And then I have my base of x with my new exponent. 1 plus 3/4 is going to be 7/4. Okay. And you can also rewrite that as 6 times the 4th root of x, and then the 4th root of x is raised to the 7th power. So this and this are equivalent, right? That's going to help us with finding the domain later. All right, so for part B, we're dividing. So we have 6x, again, 6 to the first and x to the first, all divided by g of x, which is x to the 3/4 power. Right? So when I have the same base of x on top and bottom, so I'm going to use the rule where I subtract exponents. So I still have 6, and then I'm going to have my same base of x, and my exponents are going to be subtracted. So now it's 1 minus 3/4. So when I find that, let's see, I'm still 1 minus 3/4. I'm going to do a little side problem. So I'm going to multiply 1 by 4/4. So I have 4/4 minus 3/4. So I keep the same name of 4 and I subtract, so that would be 1/4. So, and since 1/4 is positive, then it's going to stay in the numerator. So I have x to the 1/4 power, which this is going to be the same thing as 6 times the 4th root of x, which will help us with the domains. So now we want to find the domains. So just like our previous example, it's a 4th root, so I can't put a negative in under that and get a real number back. It would be an imaginary. So our domain for actually both of them is going to be x is greater than 0. This one is going to be greater than or equal to 0. And the domain for B is going to look a little different. So this is what we have, but our very original one, if you look at our original one, of 6x over x to the 3/4 power, okay? Before we simplify, we still need to take into account the domain. So if x was equal to 0, I would be dividing by 0. So this domain is going to be x is greater than 0. So not equal to, because before I simplify, if I plug 0 in for x, I would be technically dividing by 0. So this is strictly greater than, where a could be 0. Okay, and that is that. Just really quick though, if we had 6 times the cube root of x, our domain would be all real numbers because you can do cube root can have a negative under the radical as well as a positive. Okay. All right, oh good, word problem. All right, so please pause this and read it to yourself and try to figure out what's going on and see if you can set anything up. Okay, so we are going to find, we're going to find the product of R of M and S of M. Okay, so, all right, and R is the heart rate in beats per minute, and S is the lifespan in minutes, and they're related to body mass. All right, but the first thing we're going to do is just multiply. So I have 241 m to the negative 0.25. And I'm going to multiply that with 6 times 10 to the 6th, m to the 0.2. Okay. All right, it looks kind of crazy, but we can do this. So the first thing I'm going to do is put the numbers together. So I have 241 times 6 times 10 to the 6th. So I can do that on my calculator. And then I'm going to take m, they both have the same bases, and when I multiply, I'm going to add the exponents. So this is going to be m, and then negative 0.25 plus 0.2. Okay, so that's what we have so far. Okay, so when I put this in my calculator, I'm going to get, well, when I multiply 241 by 6, I'm going to get 1,446, and that's going to be times 10 to the 6th. And then when I add my exponents together, I'm going to get negative 0.05. Okay, and I'm still wanting to do scientific notation, so the decimal is hiding, but it's right there, so I'm going to move that 1, 2, 3 times. So I have 1.446, and then that would be times 10 to the 3rd, and then times 10 to the 6th, times m to the negative 0.05. And then I'm just going to combine these. So I have 1.446 times 10 to the 9th times m to the negative 0.05. All right, so we multiplied them. Now we got to figure out what it means. Okay, well, we multiplied, R was, if you remember, R was the heart rate, and S is the lifespan. So R was the heart rate per minute. Lifespan S was in minutes. So when we multiply the heart rate by the lifespan, it gives the total number of heartbeats over its entire lifetime. So just in case you wanted to know the total heartbeats of a white rhino, now you do. So you can rest easy tonight. For guided practice, it's very similar for what we did in examples 1 and 2. And then for number 7, this is the body mass, right? That is m. So we found our equation. We found 1.446 times 10 to the 9th. And then this was m to the negative 0.05. So all you're doing, if that's m, you're just taking this and plugging it right there. All right, so have fun with that with your calculator. Composition. Composition is very fun. We're combining two functions together. So we're going to slow this down a little bit. First, if you need to understand what f of 3 means. So if f of x was equal to 2x plus 1, f of 3 these are directions. Okay. Those are directions. That says plug 3 in for x and simplify. Okay, those are directions. So we're not going to subtract it, add it, nothing. So, all right, so I'm going to find x. Look, there it is. And we have 2 times 3 plus 1. So f of 3 is going to be equal to, let's see, that would be 6 plus 1, which is 7. And I found, so that would be finding f of 3. Okay, when we combine two functions, for example 4, it says find g of f of 3. Okay, so we're going to work from the inside out. So we are going to start here. So the first thing we're going to do, we're going to ignore the g and we're going to find f of 3. Okay, those are directions. So f of x is right here. So I have 2 times 3 minus 7. And so when I simplify that, I get 6 minus 7, which is negative 1. Okay, so I found f of 3. F of 3 is actually negative 1. So I'm going to replace, all right, so I had g of f of 3. Hold on. G of f of 3. Okay, I know what f of 3 is. That is equal to negative 1. So now I'm going to find g of negative 1. So when I do that, I look at my g function, which is x squared plus 4. And so I'm going to plug in negative 1 because that's technically f of 3. I found it right here. And so this is going to be negative 1 squared is positive 1 plus 4 is 5. So altogether, g of f of 3 is equal to 5. Okay, and we'll practice that some more. But I look up here and I notice my answer is right here at D. So the answer is D. For composition, it's a little bit more difficult, but we can do it. Little steps. Okay, so F, look at A. A is F of G of X. All right, so let's look at what G of X actually is. So G of X is equal to 5x minus 2. So this is equal to F of 5x minus 2. Okay. So these are directions. So when it was f of 3, we were finding x and replacing it with 3. Now we're taking 5x minus 2 and replacing it with x in our function. So in words, it means find x in the f function and replace it with 5x minus 2. Okay, we're going to come back to that for a minute. So for this example, right here, so f of 3 meant directions. These were directions. So in our terms, f of 3 meant find x in the f function and replace it with 3. And then after that, we simplified. Okay. So we're doing the exact same thing with composition. Instead of it being 3, now we're going to find the x in the f function and replace it with 5x minus 2. So let's see, this is going to be equal to, so our f function is right here, right? So I'm going to find x, so x is right there. So that's our f function. And so this is our 5x minus 2. Now I just replaced it. And then from there, I'm going to simplify. So all of this is unhappy upstairs, so I'm going to bring that downstairs. 4 is 4 to the first, so that stays upstairs. And then downstairs will be 5x minus 2, and then that is done. All right, I found x, I replaced it with 5x minus 2, and then I simplified. Okay, so let's look at part B. Part B is g of f of x. So pause it, see if you can write the sentence I wrote in green. Right. That we are going to find x in the g function and replace it with what? Well, what is f of x again? So we have g of something, and f of x was 4x to the negative 1. So 4x to the negative 1. So we're going to find the x in the g function and replace it with 4x to the negative 1 power. So g was 5x minus 2. So I'm going to leave a little space because we're going to replace that x with our 4x to the negative 1. So right here. Okay, so we replaced it, and now all we have to do is simplify. So this is going to become, become, let's see, 5 times 4 is 20. So we have 20x to the negative 1 minus 2. And then 20 has an exponent of 1. And then this is unhappy. So we're going to take that downstairs. So now we have 20 over x to the first minus 2. And that is our final answer. Okay. All right, so for part C says we're going to do f of x. So in words, we're going to find x in the f function and replace it with, well, what's our f of x function? So we have this is equal to f of, and then our function is 4x to the negative 1. Okay. So we're going to replace it with 4x to the negative 1. All right, so our f function is that. So we have 4. I'm going to leave a little room for our new x. Okay. So that's equal to this, right? So, and then now we're going to simplify. So we took our new x and we put it back into our f function. And then all we have to do is simplify. So this is the same thing. I'm going to first kind of technically distribute the exponent. So I have 4 times 4 to the negative 1 power, and then negative 1 times negative 1 is x to the first. And then this 4 is technically 4 to the first. So when I add those exponents, I'm going to get 4 to the 0 power times x to the first. Anything to the 0 power is 1. So this becomes 1 times x to the first, which is just x. All right, so that is all our functions, and now we're going to find the domain of each of them. Okay, so I wrote our final functions down here, just so it's a little bit more clear when we're finding the domain. So for part A, we're concerned about dividing by 0. So I'm not sure exactly what makes the denominator 0, so I'm going to set it equal to 0 in C. So I have 5x minus 2 equals 0. When I add 2 to both sides, I get 5x equals 2. When I divide, I get x equals 2/5. All right, so that means when I plug 2/5 back into my function, I'm going to get a 0 in the denominator. So my domain is going to be all real numbers except 2 over 5. All right, for part B, I can see that if x equals 0, I'm dividing by a 0. So our domain is going to be all real numbers except x equals 0. And for C, The domain, I can plug whatever I want in for x and I'll get a real number back. So our domain is going to be all real numbers. Okay, so that's how you do those. I think the key for composition is just to go, just take it step by step. Don't try to rush the process. And then just follow these notes. All right, and then we have a multi-step problem. So awesome. So please pause it, figure out what's going on. Okay, so this is actually comes up all the time when you go shopping, especially if you have a gift certificate and they're offering you a percentage off. I've walked out of the store paying a little bit less than probably the person in front of me because I told them to ring it up in a certain order. So this actually will help you when you go shopping. So let's see, let's find the total amount of the purchase first. Okay, so we're going to use composition. So overall, we're going to find the sale price of the purchase when the $10 gift card or gift certificate is applied before the 15% discount. And then we're going to find the sale price of the purchase when the 15% discount is applied before the $10 gift certificate. One's actually cheaper for you, although not many people know that. So this will be important, especially if you get gift cards for your birthday or for Christmas. All right, so step one, let's find the total amount of the purchase. And the total amount of the purchase, and so we spent $30 on a can of paint plus $25 worth of painting supplies. It's probably a small room that we painted, very small, and so we had total amount was $55. Step two, so we want to find two functions and compose them. So step two is find the functions. So we want to find a function for the gift certificate, and we want to find the function for the 15% off. So we're going to let x be the regular price. And then f of x is going to be our function. F of x is going to be the price after the $10 gift certificate. We're just going to call it a gift card because that's what people do now. All right, and then g of x is going to be the price after the 15% is applied. After the 15% discount is applied. Okay, so our f of x, so see, if x is the regular price, they're going to ring up everything and then they're going to get a total and subtract the $10 gift card. So for f of x, it's x minus 10. For g of x, they're going to ring everything up, and then they're going to subtract 15% of that purchase. So if this is like 1x or 1.0x, and so when I combine that, that's going to be 0.85x. So we're actually paying 85% of the full price after the 15% discount. Okay, and then step 3 is going to be to compose the functions. Okay. This is the last example, so if you can hang on, we are technically almost done. All right, so we're going to compose the functions. Okay. So G of f of x, this represents the sale price when the $10 gift card is applied before the 15%. Okay. So basically you went in to go shopping, they rang up your stuff, they swiped the gift card, and then they applied the 15% discount. So with our functions, so that's going to be G of f of x, okay, which means we're going to, f of x is actually x minus 10, which means we're going to find our x and g and replace it with x minus 10. Okay. So g was 0.85, 0.85, and then x. So x is now going to be x minus 10. Okay. And we can leave it like that, or we can simplify that to 0.85x minus 8.5. Okay. Okay, so that's one function. Okay, the other function is when they ring up everything and they give you the discount, then they take the $10 gift card off. So that's the sale price. Sale price is what you pay for when the 15% discount is applied before the $10 gift card. It's usually how stores do it, but I've had some salespeople try the other way, and I tell them, no, 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 please give me the discount first, and then I will give you the gift card. All right, so we're going to take F, and we're going to compose it with G of X. And G of X is equal to 0.85x. So we're going to find our x in our function, and we're going to replace it with 0.85. So our function for f was x minus 10. So we're going to do 0.85x minus 10, and that's our function. That's our new function. Okay. Okay, we're almost done. The last step is going to figure out how much we actually paid. So for step 4, the full price was $55. Okay. So G of F of 55. Again, they take the $10 gift card, they swipe that, and then they give you the percent off. So that function was 0.85, and then we're going to times $55 minus 8.5. So when they take the gift card off first, then they give you the 15% discount, you end up paying $38.25, okay, which is not bad. And then for the other way, so they ring up all your stuff, they give you a discount, and then when you pay, you give them the gift card. That would be $50. You're paying 85% of the full price. So we multiply 85% times what you're paying, which was the $55 for this problem. And so when you put that all in your calculator, you are now paying $36.75. So you're saving money when they apply the percent off first before they take your gift card. So, which is not a big deal if you're painting a teeny tiny room, but if you're painting a whole house, you definitely want them to give you the discount first. Okay, and that is the end of the lesson, but let's look at the guided practice. All right, so I think everything you can do, number, let's see, number 8, 9, 10, and 11, so for number 8, find f of 5 first, and then whatever number you get, you're going to plug that in for your g. So just work from the inside out. Okay, for 13, it's the same idea, but your gift card is now $15 and your discount is 20. So you're going to look at your step 4 and your step 3, right? And you're going to figure out what changes. Okay? All right, so good luck with that.